Now let's talk about how we name aldehydes and ketones, how we can communicate the structure of aldehydes and ketones by the name that we put together for them. So we've talked a little bit about acyl groups before. There are a few common acyl groups. Remember, an acyl group is a carbonyl, and that carbonyl carbon is bonded to a few different things, can be acyl groups. So let's see, we have our carbonyl and bonded to something. And then we'll do 3 different examples where we have a different group also bonded to that carbon. So we'll start with just drawing out that base structure here. Carbonyl bonded to something. Okay, the first common acyl group name we'll talk about is when that carbon is bonded to a hydrogen. This is called a formyl group. As far as the substituent goes. So a carbonyl with a hydrogen bonded to something else, that's a formyl group. If that carbon is bonded to a methyl, this is called an acetyl group. And then if that carbon is bonded to a phenyl, let me scooch this over. This is called a benzoyl group. Now remember, pH represents a benzene ring substituent. Okay, so these are 3 common acyl groups. There are others, but we'll focus on these 3. And then sometimes when we name aldehydes, well, not sometimes, there are some aldehydes that we'll name here. The suffix is sometimes just al or aldehyde. So we'll look at some aldehydes. We use al or aldehyde suffix. So let's draw out 4 molecules and then we'll name all of them. So here we have a carbonyl carbon bonded to 2 hydrogens. All right, we have our 4 hydrogens, or 4 aldehydes drawn. Remember, aldehydes are when we have a carbonyl with the carbon bonded to a hydrogen. So we see that each of these have the carbonyl carbon bonded to at least 1 hydrogen. So these are all aldehydes. The first aldehyde that we've drawn, we have 2 hydrogens. And if we look just above to the common acyl groups, when the hydrogen is bonded to a carbon, that's a formyl group. When that carbon's bonded to another hydrogen, we know for sure that's an aldehyde. So the molecule name for this is formaldehyde. So the aldehyde part tells us we have a carbonyl carbon bonded to one hydrogen. The form part tells us that carbonyl carbon is bonded to another hydrogen. So we have formaldehyde for that molecule. Second molecule, we have a phenyl ring. If we look above to those common acyl groups, phenyl as the substituent in an acyl group is a benzoyl group. When we have that carbonyl carbon bonded to a phenyl ring and a hydrogen, it's an aldehyde with a benzoyl group, and we call that benzaldehyde. Next, we have a carbon chain, and at the end of the carbon chain, we have an aldehyde group. When we have molecules like this, we need to count the longest carbon chain. So we have a total of 4 carbons, 1, 2, 3, 4 in the carbon chain. Remember, that's bute for 4 carbons. We have an aldehyde at the last carbon. So there's actually 2 valid names for this molecule. One is butanol. So here's the first molecule where we are using the Al as the suffix. So you can have butanol. Another valid name, we shift the first part of the name, the butan, to buter. And then aldehyde as the suffix. As long as you can name this molecule with one or the other name, that is sufficient. But if you see either one of these names, you should know what the structure is. So you should be able to draw the structure given either of these names. This last example, we have another carbon chain. We have another 4 carbon chain. And then we have a methyl group. The way I've numbered it now shows the methyl group at carbon 3, but the correct numbering for naming purposes is to give the carbonyl carbon number 1, or at least the lowest number possible. So in aldehydes, that's always carbon 1. It has to be at the end of the chain because it must be bonded to a hydrogen. So we'll give that carbon 1, 2, 3, and 4. So we have a methyl group at carbon 2. So this is 2-methyl butanol, or 2-methyl butyr aldehyde. Just so we're consistent, I'll shift the numbers from butanol so that the numbering is correct given how we would number for naming. So we give the carbonyl carbon number 1, and then 2, 3, and 4. Okay, so this is naming for aldehydes. We'll do some more practice in class. We have the Al or aldehyde suffix. And if you have one of these common acyl groups, then you use these special names, the formal, the acetyl, or the benzoyl group. So now let's do some names for ketones. For ketones, we use the ONE suffix. So we will draw 5 structures this time and then name all of them. So the first one has 2 methyl groups bonded to the carbonyl carbon. Second one, we will have a methyl group and a phenyl group. Next one we'll have two phenyl groups. Then we will have a carbon chain with a ketone, and then we'll do a ring with a ketone. All right, this first molecule with the two methyl groups. Oh, again, let's note we're working with ketones, so the carbonyl carbon is bonded to two other carbons. They can be saturated carbon chains or aryl groups. Either way, we have a ketone. So the first one, we have two methyl groups. Remember that a methyl group on a carbonyl right here is the acetyl group. So if we have an acetyl group and it's a ketone, this is acetone. This is what we use in lab. This is what we use as nail polish remover. That's an acetone molecule. It is a ketone. Next we have another acetyl group and a phenyl ring. So we have conflicting names up here, benzoyl group or acetyl group. In this case, we use the acetyl group as the first part of the name, and then phenone is the last. So we use that phenyl part of the name to put the last part of the name together. So we have aceto, phen for the phenyl, and then one for the ketone. Acetophenone. We have an acetyl group, a phenyl ring, and it's a ketone. So that's what each of those parts of the name mean. If we have two benzene rings, we will still use the phenone suffix, and then we'll use the benz prefix for the other phenyl ring. So we'll use benzophenone. This is another part of a ketone name, the phenone, that you should remember. Or if that ketone's bonded to a aromatic ring, a benzene ring, we use that phenone suffix. Next molecule, we have a 5-carbon chain. We want to give the ketone the lowest number when we are numbering for naming. So we'll start on the right side and work backwards. 1, 2, 3, 4, 5. 5 carbons. The carbonyl is at carbon 2. When we put this name together, we use 2 for the number to tell us that the ketone is at carbon 2. Pent, because we have 5 carbons in the chain, and then pentane, because all single bonds except for the ketone, which is represented by the -one at the end. So 2-pentanone. This next one will be similar. We have 6 carbons. We'll give the carbonyl the lowest carbon number. In this case, this is a ring, and we don't need to number. We don't need to include a number in the ring. We have 6 carbons in a ring, so cyclohex. All single bonds, so cyclohexane, and then a ketone, cyclohexanone. Let's try drawing molecules, giving the name here. So we'll do some practice. And that will be the end of this video after this. So we're going to draw these molecules. All right, we have 3 molecule names up here. First one, acetaldehyde. We have an aldehyde, so I know there is a carbonyl carbon bonded to a hydrogen. The rest of the name is it says acetal, so we know it's an acetyl group. That is a methyl group bonded to that carbonyl carbon. So that's the acetaldehyde. And of course, sometimes we draw the non-bonding electrons, sometimes they are left out. It will be, if you're completing a question, it will be specific of whether you need to include them or not. Okay, now we have 2,3-dimethyl pentanal. Pentanal, again, tells me we have an aldehyde, and there are 5 carbons in the chain. So I'll put the end of the chain as the aldehyde. It has to be the aldehyde at the end because that carbon is bonded to a hydrogen in order for it to be an aldehyde. So that is carbon 1, carbon 2, 3, 4, 5 carbons so far. So we have the pentanal drawn, and then we have methyls at carbons 2 and 3. So we have a methyl here at carbon 2 and a methyl here at carbon 3, and that's 2,3-dimethyl pentanal. Now let's do this last one, 3,4-dimethyl 2-pentanone. Pentanone tells me we have a 5-carbon chain with a ketone at carbon 2, and then at carbon 3 and 4, we have methyl groups. So 3,4-dimethyl 2-pentanone.